Welcome to Brainy Kids. Get ready to test your knowledge with fun and tricky questions. Let's get started with 3 simple rules. White dwarfs represent the incredible final chapter in the life of a medium-sized star, such as our Sun. After exhausting their nuclear fuel, these stars shed their outer layers and collapse into cores no larger than Earth, but with masses comparable to the Sun. Despite no longer producing energy through fusion, white dwarfs shine faintly as they release residual thermal energy, slowly cooling over billions of years. These stellar remnants are incredibly dense. A teaspoon of white dwarf material would weigh billions of tons. White dwarfs can sometimes reignite in a supernova explosion if they acquire extra material from a companion star. By studying their cooling rates, astronomers can estimate the age of stars and galaxies, making white dwarfs valuable cosmic clocks. Their extreme properties and role in stellar evolution provide scientists with a deeper understanding of the universe, including what might happen to our own Sun in the distant future. True or false? White dwarfs are larger than the Sun, but smaller than Jupiter. False. White dwarfs are smaller than Earth, despite their mass. What type of star becomes a white dwarf? Medium-sized stars like the Sun. Fill in the blank. A white dwarf is the final stage of a blank star's life. Medium-sized. Fill in the blank. White dwarfs shine faintly as they blink over billions of years. Cool. How are white dwarfs formed? After a star sheds its outer layers, fill in the blank. The first white dwarf discovered is called blank. Sirius B. True or false? White dwarfs no longer produce energy through nuclear fusion. True. Fill in the blank. A teaspoon of white dwarf material would weigh billions of blank. Tons. What is the approximate size of a white dwarf? Same as Earth. Fill in the blank. White dwarfs can sometimes reignite and explode as a blank. Supernova. True or false? All stars become white dwarfs at the end of their life cycles. False. Only medium-sized stars become white dwarfs, and massive stars become neutron stars or black holes. Fill in the blank. White dwarfs are incredibly blank, packing a sun-like mass into Earth-like volume. Dense. How do white dwarfs shine? By releasing stored thermal energy. Fill in the blank. The sun will become a white dwarf in about blank billion years. $5 billion years. Fill in the blank. White dwarfs act as cosmic blank to estimate the age of stars and galaxies. Clocks. Why are white dwarfs important for understanding the universe? White dwarfs provide critical insights into stellar evolution and the aging of galaxies. By studying their cooling rates and properties, astronomers can estimate the age of stars, star clusters, and even galaxies. Additionally, white dwarfs help us understand the life cycle of stars like our Sun and the physics of extremely dense matter. True or false? White dwarfs can emit light even though they no longer undergo nuclear fusion. True. What happens to a star before it becomes a white dwarf? It expands into a red giant. Fill in the blank. The dense material of a white dwarf is supported by blank pressure. Electron degeneracy. If a white dwarf is located 1.5 trillion kilometers away and light travels at 300,000 kilometers per second, how long does it take for the light to reach Earth? To calculate the time it takes for light to travel from the white dwarf to Earth, we use the formula time equals distance divided by speed. The distance to the white dwarf is 1.5 trillion kilometers, and light travels at 300,000 kilometers per second. Dividing 1.5 trillion by 300,000 gives us 5 million seconds. Converting that into days, we find it takes approximately 58 days for the light from the white dwarf to reach us. This formula helps us understand the relationship between time, distance, and speed in the vast expanses of space. How long does it take for a white dwarf to cool completely? Billions of years. If a white dwarf's light takes 10 years to reach Earth and travels at 300,000 kilometers per second, how far away is it? To find the distance, we use the formula distance equals speed multiplied by time. Light travels at 300,000 kilometers per second, and over 10 years, 300,000 multiplied by 10 amounts to about 94.6 trillion kilometers. This immense distance reminds us of the vast scales at which celestial objects exist. True or false? The sun will explode as a supernova before becoming a white dwarf. False. The sun is not massive enough to explode as a supernova. Fill in the blank. White dwarfs cool and fade over time because they no longer produce blank. Nuclear energy. Which element primarily makes up the core of a white dwarf? Carbon and oxygen. Fill in the blank. A white dwarf in a binary system can create a type blank supernova. One F. True or false? White dwarfs are the densest objects in the universe. False. Neutron stars and black holes are denser. Fill in the blank. White dwarfs are often referred to as cosmic blank because of their long-lasting presence. Fossils. What can trigger a white dwarf to explode as a supernova? It accumulates material from a companion star. If a star emits a pulse of light that travels 1,000 kilometers in 5 seconds, what is its speed? To calculate speed, we use the formula: speed equals distance divided by time. The light pulse travels 1,000 kilometers in 5 seconds. Dividing 1,000 by 5 gives a speed of 200 kilometers per second. This formula helps us measure the velocity of celestial phenomena with precision. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy Friends.